All right, lesson 93, dividing polynomials. So we're going to jump right in, and we're going to start with dividing a polynomial by a monomial. So that means there's one term. Remember, mono means one. Monomial. Okay, so for this example, we could have something like 8x cubed plus 2x squared plus 4x divided by 4x. Okay, when it's just dividing by this one term, we're going to divide each individual term. So we're going to write 8x cubed over 4x plus 12x squared divided by 4x plus 4x divided by 4x. And we're going to get the same three terms back. It's just we're going to divide them. So 8 divided by 4 is 2. X cubed divided by x is x squared because we subtract the exponents. Then plus 12 divided by 4 is 3. X squared divided by x is just x. 4 divided by 4 is 1. And x divided by x, there's no exponents left, so we don't need an x. This is our final answer. Okay, dividing by a monomial is probably one of the easier ways to do this. Okay, let's talk about if it's a binomial. So there are a couple ways to do this. The first one is by factoring. I know we all love factoring. So let's try this. All right, we're dividing polynomials by binomials, and remember that means two terms. Think about a bicycle with two wheels. So if I have x squared minus 6x plus 9 divided by x minus 3. One way to go about this is to think about factoring that first polynomial. So I need factors of positive 9 that are going to add up to negative 6. So I know they both have to be negative, and 3 times 3 is 9, and 3 plus 3 is 6, so that'll work. So I've got x minus 3 times x minus 3. Then divided by is the same as putting it over x minus 3. Well, we learned this in the last lesson. Since this term is the same as this term, they can cancel out, and I'm left with x minus 3 for my answer. Okay, sometimes factoring is a little bit complicated, and then we can use long division on polynomials. And I know that sounds kind of crazy, but it's actually pretty efficient if we know what we're doing. So let's talk about long division. It looks the same as if you do long division with numbers. It's just now we've got letters involved. So if I've got negative 25x plus 3x squared plus 8 divided by x minus 8. Okay, first order of business is to put your equations in standard form. So like we've got x squared that comes after just an x. So that's not standard form. We've got to switch those around. We put the most exponents first and work down to the least amount of exponents. So we've got 3x squared minus 25x plus 8 divided by x minus 8. Now that we know that, okay, so we're going to write this in our division bar. 3x squared minus 25x plus 8 divided by x minus 8. So I'm going to look at my two first terms. So just this x and this 3x squared. I'm going to say, what do I have to multiply x by to get 3x squared? Well, I'm for sure going to need to use a 3. and it's got two terms, so it has to go after the second term here. And then to get to x squared, I'm going to have to multiply by an x. So if I multiply 3x times x minus 8, I get 3x squared minus 3 times 8 is 24x. And I'm going to subtract these. So these cancel out. That was what we were trying to do. 25x, negative 25x, minus negative 24x is actually plus positive 24x. So this is actually negative 25 plus 24. So that leaves us with negative 1x. Drop down the next term, plus 8. Well, I've got a positive 1x here. So to get rid of the negative 1x, I'm going to need to put negative 1. So if I multiply negative 1 times x minus 8, I get negative 1x. Negative 1 times negative 8 is plus 8. And if I subtract these, this cancels out, this cancels out, there's nothing left over. So this would be my answer, 3x minus 1. Okay, let's try another example of long division. Got 13x squared plus 5x minus 42 divided by x plus 2. And these are in standard form, so we don't have to worry about that. We're going to go straight to writing our division bar. Okay, so now, whoops. I've got x and 13x squared. What am I going to have to multiply 13x by, what am I going to multiply x by to get 13x squared? Well, for sure 13. And remember, it always goes over the second term. And to get x squared, I'm going to need another x. So 13x times x plus 2 is 13x squared plus 26x. We subtract those. These cancel out. 5 minus 26 is negative 21x. And we write down the next term, minus 42. So then, what do we have to multiply x by to get negative 21x? In this case, negative 21. We multiply, subtract, this term cancels out, negative 42 minus negative 42 cancels out, and we're left with 0. This is our final answer. Now, just like when you divide numbers, sometimes there is a remainder, and that's okay. We can definitely figure out what to do with those remainders. So let's talk about that real quick, because that is the last thing we have to talk about. So if I have 2x squared minus 9 minus 7x divided by negative 4 plus x. First things first, we need standard form. So x squared, or 2x squared, minus 7x minus 9 divided by x minus 4. Now we can use the division bar. So got 2x squared minus 7x minus 9 divided by x minus 4. Well, to get x to be 2x squared, I'm going to need to multiply by 2x. And then I get 2x squared minus 8x. If I subtract, these cancel out. This would be positive 1x minus 9. To get x to be 1x, I'd have to multiply by 1, so we're really not changing anything here. X minus 4. Subtract, this first term cancels out. negative 9 minus negative 4 would leave us with negative 5. And we're out of room. There's no other terms to keep dividing. So this is our remainder. Okay, so think about the ways you've written remainders for regular numbers before. Okay, when we have done them in the past, sometimes you write them as a fraction. That is what we are going to do here. So basically, we're going to take this negative 5 up to here. We're going to write minus 5 over, and we're going to write our denominator right here, x minus 4. And this would be our final answer. Okay, so you just write the remainder as a fraction. You should have everything you need to go ahead and start the work. If you have questions, make sure you're getting a hold of me, and I'll help you as best as I can.